Greetings, everyone. What we're going to be doing today is, of course, on Tuesday, we were introducing these large language models. And I wanted to point folks to our folder on additional AI readings. And maybe before I forget, the AI assignment is nice and easy, very appropriate, I think, for going into spring break week. We've got a list of different tutorials from cognitiveClass.ai focusing on AI or AI applications. And that includes, by the way, machine learning and deep learning. And you just need to pick your favorite tutorial. And the only thing is, if you've already done prompt engineering, or if you've already done machine learning with Python for an earlier session, pick something else. And there are a few tutorials like AI ethics, and AI concepts that are all very, very short. So that's the only one where, you know, I recommend that you do all three. So, but this one, again, if you have already done this assignment for another tutorial, choose something else from the list. Yeah. And you can kind of look through. And again, and if you're going away for spring break, you'll still have plenty of time when you come back to finish off one of these tutorials. Okay. So having said that, yes, so what do we have under the readings for this week? Well, I have a bunch of different topics. And I found this nice little article on, again, giving an overview of machine learning. So if you remember, this whole idea of, I was going to say, using machines to classify, to predict, to be able to do intelligent things, that is something, you know, we started actually on that even hundreds of years ago when we started to work out statistical concepts and then started to figure out how the computer could help implement those statistical tools for us. And then as the data got more complex, as it got bigger, as there was more different types of data that we wanted to work with, we started to expand into other approaches, data mining, machine learning, neural networks, and then the neural networks got more sophisticated and deeper, and so we started calling that deep learning. And now we're applying that deep learning to these language prediction models, which we are calling large language models. So this is a nice little overview, you know, talking about just machine learning and the fact that one of the things that we like to do a lot of is being able to classify and predict things. And we also like to find patterns or associations that could be very useful to us in decision making or taking action. So this is a nice overview article, and you notice it's quick and easy. So this is like a 3-minute read. And then I wanted to talk about another article which builds on that and starts talking about some of the common models that are out there, often when we want to classify something. So And keep in mind, these can also in some cases be used for predicting. The difference between predicting and classifying, and in a way, both are a prediction. Usually when someone says to me, I want to make a prediction, it's kind of like someone trying to predict a numeric value. Can you predict how many inches of rain or centimeters of rain are we going to get over the next 7 days. But a classification is more of a prediction when the variable is more of a qualitative. It's a nominal or ordinal. So if I say, could you classify for me, or whether this weekend will be a nice weekend or not, that is a classification versus making a numeric prediction. So I guess the way I think about it is prediction is usually when I'm trying to forecast what I think a quantitative variable might be, where a classification is where I'm trying to predict what a qualitative attribute might be. And this little article kind of tells you what are some of the different options that are out there. And again, some of these are good for both predicting and classifying, while others are more used for classifying than they are for predicting. And certainly, there are other types of regression that are very good for predictions versus classifications. So why is this important? Well, of course, it gives you a little bit better understanding of what are some of the machine learning models that are out there for you to play with. And let me just mention, let me put this out in the whiteboard. The reason I want to mention that is, of course, this is a good time for you to narrow down on a data science project. So here's I'm going to just say one idea for a data science project, and that is to, for example, pick a classification challenge, from Kaggle or other source that you are interested in. And so here's how that report might look like. So it could start off with an introduction, and that introduction is where you explain why that classification problem is interesting and in particular useful, i.e., why is it important? Okay. So for example, maybe you have a classification problem trying to forecast whether someone is at high risk of diabetes or not. And so you would want to, again, this is where you can go out to the internet, the library, find sources that talk about, why having such a classification model, why is it useful, who would use it, why it is important, why is it something that we would want to be able to do. Okay? And then you can have your objectives. And your objectives can be as simple as you would like to come up with a classification model that A addresses this challenge, and B allows you to compare and contrast several different machine learning models for this challenge. Okay, and what you can then do is usually then, after you have your introduction and your objective. Now, this next section can kind of vary a little bit. This is basically your literature review, where you talk about what others have been doing to address this challenge. So sometimes that's a really good way to go about giving folks the background and to kind of show that you have done some homework in this area. But I'm going to expand this to be a literature review, and this could also be the resources that you used. And this is a great place for you to list out, and this is where you want to just really explain the various sources that you use to help you to that you use to help understand. How about this? What others. Let me just move this around. Let me see if I can move this. Yeah, there we go. There we go. Yeah, here we go. Explain the various resources that you use to help understand what others have been doing in this challenge area. You can also use this section to describe the tutorials, reference materials you use to do this project. You can also use this section to describe what is innovative or unique about your approach. And by the way, that last statement is particularly important if you're doing a dissertation. Because what makes a master's different from a dissertation is in a master's project, you are showing that you're able to reproduce or apply the current techniques, the current approaches. You're able to show your mastery of the current state of the art. With a dissertation, part of the reason that you have the literature review is to really describe what research is being done in this area, and you're comparing, contrasting what you're proposing with what other research is being done, because you want to show that you are making a contribution. You're pursuing a different take, you're developing something novel, you are bringing a new perspective in, maybe you're bringing in a new technology or a new way of doing things, but basically you've got to show that you're doing something that is going to add to the literature, where with a master's, it's sufficient for you to be replicating the literature. Okay. And then what else would you need? Well, then your next section could be the data. So this is where you describe your data set, where it comes from, maybe its history, give a schema of the data. And by schema, what we're saying is, the reader has not seen this data set. So you want to provide a description of this data. And that's very important. Some students just put a URL link, which is a kind of a way of saying to the reader, hey, look it up yourself. That's a little cheeky. You have to remember is you want people not to be irritated when they're reading your report. And so, you wouldn't want to be watching a movie and have a really important part of the plot, and up comes a URL that says, hey, you need to stop watching the movie and go to this URL and look up this information yourself. So as I say, you want your project report to really flow. So you want to make sure that you're kind of anticipating questions that people will have. And you want to make sure that you're putting it in. And by the way, I'm not saying don't put in the URL, but you want to put in enough information into your report that folks really can keep reading. They can understand what the data is and its, history, its background. They understand, oh, these are the different fields. Some of this information you could even put into the appendix. And again, you can always say, for more, here's the URL where I obtained this information. And that's fine. You always want to give the reader the option, if they're really interested, to be able to find your source material. But this is where then your next section could be then applying the different, this is where you could apply several different ML machine learning models to compare and contrast their performance. So this is how it links back to that list of different machine learning models. You might want to go through and pick out, read up on several of these different models. They are available in a number of different Python libraries, and there's a lot of good blogs or tutorials. And again, you can reference all of that. You can list, hey, this is where I found the information on the XG boost. Here's what it is. This is what I learned about, a little bit of its history and background. And this is how I learned, which Python library to use and the code to use in order to develop the model and to generate its performance statistics on my test and training data so that I could then do the comparisons. Yeah. And then you're going to finish up with, I'm kind of running out of space, but then you would have your closing thoughts on, what you accomplished, what you learned, and, any future improvements. Because, you have a limited amount of time, and obviously, maybe you were able to compare and contrast, three or four different models, but maybe there were some additional ones or going in deeper that you didn't have time to do. And one final note is don't forget to have your appendix. And the two things that you may want to include here is one, have a breakdown of the hours you put into the project. And that's very important. Typically you're looking for something, 30 to 40 hours. And it's fine to have more, but I don't want people to be at a disadvantage. If you ended up just putting 2 hours into the project, keep in mind you're going to be graded against folks who may have put 35 hours into the project. So think about that. And then the other thing that is, of course, you can have, make sure you have your references. Okay, so those that would be like the title, author, date, and a source. And URLs are great here, because that's great. If I can just, click on a reference and have it pop up, that's wonderful. And by the way, if you have some extra results or extra code or extra things you wanted to include, that is just fine. But I wanted to put that in there because, and again, we'll go back to sharing the application screen. Yes, if you are looking for, well, how do I turn a Kaggle challenge into a nice data science report? Yes, just picking a good classification problem and trying out some of these different techniques is a great way, comparing, contrasting the pros and cons of each one is great. And again, you don't have to do 8. You know, pick 3 or 4 that are particularly useful or you feel might be very applicable to your problem. So let me just pause for a moment. This is a good place to take questions. Okay. Okay. And we mentioned that as things get more complicated, like so, what if you're supposed to want to classify animals based
Doris,
on?
I have a question.
Sure.
It's about the projects. The recording. Are we supposed to record the entire project, the progress of it, or we do a PowerPoint and then do the recording?
Oh, yes. So that's a great question because we talked about the project, but if you want to know more about the presentation, you're going to do just a 3-minute summary. So you're not going to put together, let me put it this way. You're going to do the work for the project. You're going to write up this project report. Your presentation is going to be a 3-minute summary, and you want to essentially pretend that you have a poster session. So you have maybe one slide, a poster about your project, and someone's going to stop by, and you're going to give them a 3-minute talk. And so this is where the most important thing about the 3-minute talk is that you want to put together a nice introduction. So think about, a beginning, which you want to introduce, explain, why this is an interesting challenge that should be addressed. And then you want to, in the middle, you want to talk, give a high level of what you did for this project. And the end is sort of your closing statement of what you learned and what you feel is sort of, future directions. So again, approach the presentation that you have one slide, or if you want to think about it as one poster, and you've got 3 minutes to tell someone who stopped by to give them an overview of your project.
Okay, so just like a first page on like a Word document or a flyer or something like that.
Right. And definitely there are lots of good, you can go on to YouTube and just Google like 3-minute talks. And that is the best way to explain it, is to say, hey, look at a couple 3-minute talks and of people, presenting their projects. And you'll be like, you'll start to see the pattern. They have a nice intro, they have an overview, and then they kind of have their, closing statements. But it's high level, and it's done very conversationally. They're not reading from their report. They're not using a lot of techno jargon. It is essentially a nice, imagine, you have this long movie, but then what you're seeing, if you will, is the 3-minute summary. The little summary or overview of the movie. Okay. But I do recommend definitely they have a lot of you can just click on watch, and yes, and there we go. Just go, and they're all 3 minutes or less. And that's important. By the way, it's fine to be less. It's fine to be 2 minutes and 30 seconds. And if you end up being, 3 minutes and 15 seconds or something like that, that's not a problem. But if you find that you've been talking for 15 minutes, yeah, you need to think about, how do I get it down to 3 minutes? But the 3-minute presentation that you will, let me put it this way, you'll do the work for the report, and then I recommend do your write-up for the report. And then again, that 3-minute presentation, think of it as one slide or, one visual or one poster, and then a 3-minute summary. And again, look at a couple examples. That's the best way to get ready for that. Excellent. Anything else? Okay. So this is a nice overview of deep learning. And typically with deep learning, this is where we get into neural networks. And when we talk about neural networks, there's lots of different types of neural networks. So we saw, for example, convolutional neural networks is what they typically use for trying to classify images. But the basic idea of this neural network is its flexibility, the fact that it can handle both linear and nonlinear relationships. So we will have all the different types of data that we want to feed in. And then we've got these different, think of them as sort of mathematical layers where we can have different, each node represents, if you will, a different function point. And each node can take one, two, some, or all of the inputs. And it basically pulls it into a function. And you can use different functions. You can use linear functions. You can use different shapes of nonlinear functions. And you can have multiple layers to give you even more flexibility as to different ways that different combinations of variables can be combined together to produce some prediction or some classification. Okay. Okay. So that is, and this is a nice article that kind of summarizes the neural networks, and there's quite a bit of mathematics involved in, for example, like, well, how do we do these various weights? Notice there's a different type, recurrent neural networks, very good for text and audio. There's another type, for unsupervised learning. This is the one, transformer neural networks. That is the one that is being used in large language models. Okay, yeah. Okay, so this is a very nice overview here of deep learning. And what's very interesting, and we'll see the same thing with large language models. You might say, well, wait a second, this is so mathematical. I mean, having to derive, figuring out these functions, figuring out what the weights are, trying to understand the mathematics of how all these different layers get combined together. And you say, wow, the people who came up with this, they had PhDs in mathematics and computational engineering. And you might say, well, how can I even make use of that? Well, it's kind of like the difference between I know how to drive a car, but if you ask me, well, explain, how a combustion engine works, well, I really don't know how an engine works. I really don't know how the parts of my engine work. I really don't know how my car was put together. I mean, I know some basic parts, but basically, what do I know how to do? I know how to drive the car to get me to interesting places, or places that I want to be. And that is what's happening here. You can let somebody else come up with the TensorFlow, or come up with the, the Python library that has the convolutional neural network that you want to use. And you kind of saw that, we were able to do a tutorial, and we were able to predict handwritten numbers. We didn't know anything about how a convolutional neural network is actually operating, but we did know how to import the libraries, import the data, follow the recipe for how to get your data ready, how you feed it into the model, how you let the model do its thing, and how, we didn't get too deep into playing around with some of the parameters, in terms of fine tuning and things like that. But in a couple steps, we were able to get a basic model going. And then we had some tips on, how to produce some performance information, so we could see how accurate, how many false positives, how many false negatives, how did we do? Okay. All right. So again, if you are trying to say, well, what I want to classify are images, or I want to classify audio signals, as your data gets more unstructured, more complicated, maybe you want to pull something out from this next article, okay? All right, now here we go. I kind of went out too far, but here we're going to go a little, here we go. Okay, so now we get into, let's take deep learning now a step further. And again, this is a nice overview of, from, again, Geeks for Geeks, love Geeks for Geeks. But a large language model, think of it as a type of neural network that has been classified for predicting human language. Or, yes, I'll just, not necessarily even English language, just human language. Okay, so, and again, if we take a look at, the generative pre-trained transformer model, we had, of course, these different versions of a GPT. And this is a nice one. We do have a sense they're trained on fast data sets using self-supervised learning techniques. They can be customized, based on the type of data that they're trained on, the availability of computational resources, and what type of language processing tasks that we want to be carried out. And we get the sense that they've got many layers that takes to essentially build them. And I wanted to show you, this is really good. Here, let me do a couple things. I'm going to open this image in a new tab. And what I'm going to do is I'm going to pull this over here. Yay. Okay. So this is, in essence, what it takes to build a large language model. This is the architecture behind a large language model. And this is the blueprint. So so look at, for the folks in class, just look at the picture here. So we start in here, we have, all this information that we've been scraping and gathering up. And we feed that in. And, we mentioned on Tuesday that what happens is everything that we're feeding, those words, subwords, essentially has to be turned into a continuous vector representation. That is, we've got to make sure that each word or subword, essentially we treat it as a token, and then everything we want to capture about that token, we have to store in a numeric vector representation. And that's capturing any sort of semantic or syntactic information about each piece of that input. And then we go to what's called positional encoding, and that's added to the input embeddings to provide information about the positions of the tokens, because transformers do not naturally encode the order of the tokens. So this enables the model to process the tokens while taking their sequential order into account. So that's essentially saying, words can have different meanings depending on where they are in the sentence. So that's why we have to we got to be a little smarter, not just take into account the word, but where is that word in relationship to the other, tokens, okay? And then we get into essentially the encoders, and this is based on a neural network technique. The encoder analyzes the input text and creates a number of hidden states that protect the context and meaning of text data. Multiple encoder layers make up the core of the transformer architecture. And self-attention mechanisms and feed-forward neural networks are the two fundamental subcomponents. So what we're looking at here is, so this is the process where we're weighing the importance of different tokens in the input sequence by computing attention scores. So this allows the large language model to consider the dependencies and relationships between different tokens in a context-aware manner. And just remember, by tokens, we either mean words or subwords or, some unit of language. Okay, and then we've got this feed forward, and that is applied to each token independently. This network includes fully connected layers with nonlinear activation functions, allowing the model to capture complex interactions between tokens. So what we've got is a giant, neural network going on. Okay. And then you'll notice here we just kind of say, okay, and then what we got here too, and then we've got also, you could have some decoder layers. This is the decoder layer enables autoregressive generation, where the model can generate sequential outputs by attending to the previous generated tokens. What you see, this multi-head attention, this allows the model to capture different types of relationships and attend to various parts of the input sequence simultaneously. And then we've got layer normalization is applied after each subcomponent or layer. It helps stabilize the learning process and improves the model's ability to generalize across different inputs. And you'll notice here, yes, and then you have you've got your output layers, and for example, this is, for example, what helps to generate the probability distribution over the next token. Okay. Okay. So this is what it takes. If you're OpenAI or your Google Gemini, This is what it's taking to basically build the engine that's going to drive your large language model. Okay. And this is a nice article. They also go into, for example, in addition to explaining this architecture, they talk about the fact that GPT is not the only thing out there. You've got BERT, you've got Roberta, you've got Bloom, and there are various things that you can use a large language model to do. And there are a number of different applications. And they mention too, because you might say, well, if large language models and you have natural language processing, what's the difference? And I think what they would say is natural language processing is actually a broader field where it actually, natural language processing also encompasses other techniques other than large language models. Okay. And so then it talks about some of the challenges in using them. But that's a nice overview of large language models. Now, as you're looking at that picture and you're thinking, oh my goodness, how in the world could I possibly get into this space? Well, again, it's that analogy is think of the large language model is basically a very sophisticated engine that somebody built to be able to predict language. So think of it as, somebody, and actually we have multiple vendors who are now selling these different engines. And what we're going to do is actually, we're going to build on that engine to say, well, look, we're not the engine builders, but we want to be the drivers. We want to be able to take this new vehicle and we want to be able to put it to use. Okay, so you may have heard this term retrieval augmented generation in context to the large language model. And so what happens is we start off with a super powerful language bits. So we start off with a large language model, and as they say, we say, this is great. Okay, we have this large language model, but we want it to put it use for a particular application. So maybe here's a great example. We want to create, let's say, a medical chatbot. And so we want to use our large language model to allow our chatbot to converse with someone who has questions about a particular ailment. But we want to make sure that it is giving the person correct information. So this is where we have the RAG model. So we don't want the LLM to just give a general answer to this question. We want to make sure that the person is getting a response that is based on a medical knowledge base. So, and of course, we want to have it everything working together. So this is a little picture. For some reason, it keeps reloading, but it starts off with a person asking a question. So that is the prompt. And keep in mind, the prompt also has to be converted into one of these vectors, embedded vectors. So it has to be tokenized and turned into numbers. And then what we're going to do is we're going to have our medical knowledge, and we're going to have to convert that into embeddings. And that is going to go into a vector database. And what we're going to have to do is we're going to take our prompt vector and compare it to our medical knowledge vectors. And if we're asking questions about the common cold, we want the large language model to help us be able to select that portion of our medical knowledge repository that is most similar or related to our prompt, about that particular condition. So then we've got our large language model that is then going to kind of help us essentially, it's going to kind of work together. It's going to generate its initial response based on its knowledge, and the retrieval system finds relevant information from the knowledge base, and then it blends these two elements to create a final response. It's going to give a much more complete conversational response to the person. So for example, the large language model acting on its own might say to the prompt, what are the symptoms of the common cold? It might just say symptoms of the common cold. So instead of just a generic, sorry, let me back up. So the LLM might just simply respond, well, first of all, it might just respond that, what are the symptoms of the common cold? The LLM on its own might just have an answer like, with the common cold, you sneeze and you don't feel well. But if the LLM can actually combine it with the medical database, it can give you actually a more complete answer, like symptoms of the common cold include a runny or stuffy nose, sore throat, cough, and mild fatigue. If your symptoms worsen, consult a doctor. Okay. So this is kind of interesting. So what happens is you've got so what happens is part of what this architecture does is it employs a technique called data chunking, which is just dividing the knowledge base into smaller, manageable segments. This improves processing efficiency and allows for more targeted searching. Okay. And again, chunking can be done in various strategies. Okay. And then we mentioned, again, we have to take any chunk of text, whether it's a sentence or a paragraph or whatever, it's got to be converted into a vector representation using, a choice of different embedding techniques. So we noticed that on Tuesday, that basically all those words get transformed into a numeric token, and associated with that numeric token is a whole host of attributes, all of which have, again, numeric representation. But this is what's going to allow us, again, to take our query and prompt that will have been tokenized and to be able to compare it with the meaning of the chunk data. And again, we're trying to find, where our prompt or query matches up with similar chunks of data in our vector databases. Okay. And so again, we use databases documents in large language models, but they're not your traditional relational database or spreadsheet data. These are these data storages of these vectors. So let's see what happens. So when a user submits a prompt, again, the LLM will first generate an initial response based on its internal knowledge. And then at the same time, the query is transformed into a vector representation using the same embedding technique used for the chunk data. The vector representing the query is then compared with the embeddings stored in the vector database using various vector search algorithms like proximate nearest neighbors. So again, we don't have, if we were talking a relational database, we would be using SQL queries. We need to have, a different way of doing that when our data is vectorized. And again, we have these algorithms that will retrieve the chunks from the database that have vector representations most similar to the topic or question posed in our query. Okay. And then again, everything then has to be orchestrated, both the LLM response and then what's coming from our medical knowledge database, and we have to kind of fuse them together to then provide, the final response, by the way, that starts off as a vector and then has to be turned back into words so that the person can understand, what the answer is. Okay. So that's a nice well, let me put this up here. Okay. And move this up here. But that RAG is really interesting because this is what allows companies to run large language models privately. So this has a nice article about the privacy challenge. But here, I think, again, I want to get down to a nice picture. Okay. So again, this is another, keep in mind that now what companies are doing is they are employing a large language model from a vendor. They could be using an AWS large language model. They could be using a Google large language model. They could be using an OpenAI language model. And that is the part that, they purchase, and that's sort of, if you will, the public part. But what is private is the fact that companies are taking their own, internal documents, and they are putting them through a software tool that basically ingests those documents, chunks them up, converts them into vector representations, and stores that knowledge base, here in this vector DB. And that's the part that's going to be private. So you have this public large language model, but this vector database has the company's internal stuff. And again, you have sort of the query that goes against this remote vector DB. It basically, you get a response there, and then that goes into this orchestrator or whatever, who then does an API call to the LLM. It then gets its generated response, and notice it goes back in. And so now we have the information coming from the company's documents combined with the response from the large language model. And then it's doing it's got a series of algorithms that it does to basically orchestrate and synthesize and produce the response that goes out to the user. Okay. So this is a nice description of essentially how you can get your large language model to give you these customized responses. Okay. And then this was very interesting. Again, I want you to focus on this picture, okay? So this is an interesting article that talks about where we're going. Oh, not that picture. Let's take a look at this picture. Okay, there we go. All right. Oh, wait a second. That's the research bot. Let me go back one more. Okay, this is the one, from text to decision making. Oh, I see what it's doing. I think it must have some protection on it. That's okay. We'll make it bigger. That'll work. Okay. So notice here, we are now going from just a simple prompt LLM to a retrieval augmented generation LLM. And then the next thing coming down the pike is agentic flow large language models. So this is what we had originally. Think about 2 years ago, 2 or 3 years ago, when ChatGPT was first open to the public. You, the user, could put in a prompt to the ChatGPT large language model, and you got yourself a response. Okay. Then the next level of large language model is that, and this is what companies started to do, is they started to add a knowledge base to enhance the accuracy and add novel information to the large language model. So again, they might be using, a license to ChatGPT or AWS or Microsoft LLM. And this vector DB, that is where the company will say, hey, we're going to create our vector database of claim forms. We're going to, or claim information, or we're going to do a vector DB of diagnosing maintenance issues, or we're going to do a vector DB of, medical knowledge. So this is where, companies are creating these knowledge bases, and then you have a user, same thing, has a prompt, but then you've got this hybrid search where it's going to go to the company's knowledge base, and then it's going to orchestrate its response with the large language model, and then you're going to get a response. And then this is what's coming down the pike, is a decision-making enabled, where the large language model can prompt the user for information, choose to add tools, interact with other agents, and affect the real world, triggering alerts, sending messages, etc. So this is where the user would be able to interface with the LLM. The LLM can turn around and say, I need more information. It could select a tool, factor in tool output, and then you have these responses, but you also will have these actions. It's not just going to be an agentic AI. It is not just providing information. It also can be providing an action. It's going to be doing something for you. Okay. And the last article, in case this comes from DigitalOcean, they have a very nice article on how to improve your prompts so that you can get better information out of your large language model. So this is a very nice article where it talks about the importance of being specific, supplying examples, providing data, specifying your desired output, providing instructions on what to do, give the model a persona or frame of reference, try putting together a chain of thoughts, taking a complex task and giving tasks, understanding the model's shortcomings, you know, approaching it experimentally. But anyway, that's a nice overview of the prompt in engineering. Okay. So so definitely check out these readings. And what else did I want to tell you about today? Okay. Oh, all right. Okay, let me share with you this. So I mentioned large language models. Think of them as essentially the latest, greatest vehicle that's on the market. And you're thinking, okay, I'm not the one that's going to build this vehicle. But now that this vehicle is out there and being produced, I want to know how I can drive this vehicle for my company. I want to figure out how I can use this engine to do stuff. And so let me talk to you a little bit about, well, we'll take a look. Just see, okay. I want to watch my time here. Okay, so one of the companies that was early into this space was a company called LangChain. And this is really, think of it as a development platform for folks who want to build applications off of a large language model. Now, when LangChain first came out, it was, I was going to say, it was sort of the first to the market. There are now a bunch of competitors coming out there. So just be aware, I have a link there just so you know that LangChain is, now you have a whole bunch of folks buying in this space. I also have some tutorials if you want to learn more about LangChain. I also have two videos. One is the Windstream AI workshop, and the other is the views from Yogesh Pandey, CEO of Hexonica, on how his company is approaching AI. But I think what I'd like to do is, let me do it like this. Let me make sure that when I share the application screen, I want to make sure I'm also sharing the system audio. And let me play a little video that'll finish off the period, explaining to you how you can create LLM applications without actually being a mathematical wizard who knows how to build the LLM themselves. So let me see if I can take it away here.
Before, but there are a lot of large language models available today.
Get me started.
Now, stop me if you've heard this one before, but there are a lot of large language models available today, and they have their own capabilities and specialities. What if I prefer to use one LLM to interpret some user queries in my business application, but a whole other LLM to author a response to those queries? Well, that scenario is exactly what LangChain caters to. LangChain is an open source orchestration framework for the development of applications that use large language models, and it comes in both Python and JavaScript libraries. It's essentially a generic interface for nearly any LLM. So you have a centralized development environment to build your large language model applications, and then integrate them with stuff like data sources and software workflows. Now, when it was launched by Harrison Chase in October 2022, LangChain enjoyed a meteoric rise, and by June of the following year, it was the single fastest growing open source project on GitHub. And while the LangChain hype train has slightly cooled a little bit, there's plenty of utility here, so let's take a look at its components. So what makes up LangChain? Well, LangChain streamlines the programming of LLM applications through something called abstractions. Now, what do I mean by that? Well, your thermostat that allows you to control the temperature in your home without needing to understand all the complex circuitry that this entails. We just set the temperature. That's an abstraction. So LangChain's abstractions represent common steps and concepts necessary to work with language models, and they can be chained together to create applications, minimizing the amount of code required to execute complex NLP tasks. So let's start with the LLM module. Now, nearly any LLM can be used in LangChain. You just need an API key. The LLM class is designed to provide a standard interface for all models. So pick an LLM of your choice, be that a closed source one like GPT-4 or an open source one like Llama 2. Or this being LangChain, pick both. OK, what else have we got? We have prompts. Now, prompts are the instructions given to a large language model, and the prompt template class in LangChain formalizes the composition of prompts without the need to manually hard code context and queries. A prompt template can contain instructions like, do not use technical terms in your response. That would be a good one. Or it could be a set of examples to guide its responses. That's called few-shot prompting. Or it could specify an output format. Now, chains, as the name implies, are the core of the LangChain's workflows. They combine LLMs with other components, creating applications by executing a sequence of functions. So let's say our application that needs to, first of all, retrieve data from a website, then it needs to summarize the text it gets back, and then finally it needs to use that summary to answer user-submitted questions. That's a sequential chain where the output of one function acts as the input to the next, and each function in the chain could use different prompts, different parameters, and even different models. Now, to achieve certain tasks, LLMs might need to access specific external data sources that are not included in the training dataset of the LLM itself. So things like internal documents or emails, that sort of thing. Now, LangChain collectively refers to this sort of documentation as indexes, and there are a number of them. So let's take a look at a few. Now, one of them is called a document loader. Now, document loaders, they work with third-party applications for importing data sources from sources like file storage services, so think Dropbox or Google Drive, or web content from like YouTube transcripts, or collaboration tools like Airtable or databases like Pandas and MongoDB. There's also support for vector databases as well. Now, unlike traditional structured databases, vector databases represent data points by converting them into something called vector embeddings, which are numerical representations in the form of vectors with a fixed number of dimensions. And you can store a lot of information in this format as it's a very efficient means of retrieval. There are also something called text splitters, which can be very useful as well, because they can split text up into small, semantically meaningful chunks that can then be combined using the methods and parameters of your choosing. Now, LLMs by default don't really have any long-term memory of prior conversations, unless you happen to pass the chat history in as an input to your query. But LangChain solves this problem with simple utilities for adding in memory into your application. And you have options for retaining like the entire conversations through to options to just retain a summarization of the conversation that we've had so far. And then finally, the last one we'll look at are agents. Now, agents can use a given language model as a reasoning engine to determine which actions to take. And when building a chain for an agent, you'll want to include inputs like a list of the available tools that it should use, the user input, like the prompts and the queries, and then any other relevant previously executed steps. So how can we put all of this to work for our applications? Well, let's talk about a few LangChain use cases. Now, obviously, we have chatbots. LangChain can be used to provide proper context for the specific use of a chatbot, and to integrate chatbots into existing communication channels and workflows with their own APIs. We also have summarization. Language models can be tasked with summarizing many types of text, from breaking down complex academic papers and transcripts to providing just a digest of incoming emails. We've also seen lots of examples where this is used for question answering. So using specific documents or specialized knowledge bases, LLMs can retrieve the relevant information from the storage and then articulate helpful answers using the information that would otherwise not have been in their training data set. And yeah, this is a good one, data augmentation. LLMs can be used to generate synthetic data for use in machine learning. So for example, a LLM can be trained to generate additional samples that closely resemble the real data points in a training data set. And there are, of course, virtual agents, as we already started to discuss. Integrated with the right workflows, LangChain's agent modules can use an LLM to autonomously determine the next steps and then take the action that it needs to complete that step using something called RPA, or robotic process automation. LangChain is open source and free to use. There are also related frameworks like LangServe for creating chains as REST APIs, and LangSmith, which provides tools to monitor, evaluate, and debug applications. Essentially, LangChain's tools and APIs simplify the process of building applications that make use of large language models.
If you have any questions, please drop us a line below. And if you want to see more videos like this in the future, please like and subscribe. Thanks for watching.
Okay, so we are
Left to their own device.
Just about out of time. But let me just see if there are any questions before we wrap up. I was going to say spring break is also a very good time if you have not done so already, and you're going to need to register for fall 2025. Do check out workday.ualr.edu. IT services will be available next week, at least Monday through Thursday, if you need any help being able to log in. And then check to see if you've got some tasks, particularly your onboarding. And then the next thing is start thinking about what classes you will need to take. And I have it on my to-do list is I'm going to work with our program coordinators. What I've been doing this week is updating our advising materials for Workday students, and also putting together some suggested course lists. So I've got those ready, and I'm just kind of maybe timing for right after spring break to, if you will, release all of that information. But if you'd like to get a head start because you'd like to work on it over spring break, just send me an email. You can help beta test my advising materials. I was going to say there's a oh yes, how's the sound? Is the sound still coming through? Okay. Yes, and sometimes we will are capturing everything on the we are capturing everything on the recording. So yeah, let me know if anyone else is having audio issues. Yeah, sometimes it's me, and sometimes it's individuals, and let me know. Anyone else? I'll just say, let me know if you can hear me. Oh, okay. Oh, okay. So, and maybe it was because we played the video and then I needed to switch back. But I was just saying that definitely check out Workday over the spring break. Let me know if you want to have an advanced copy of any of the advising materials that we're putting together. And I do encourage you, think about what you're going to do for your data project. And definitely take the time to look through the materials on large language models. Another idea for a project is maybe you would like to try your hand at playing around with LangChain. And by the way, LangChain, if you look at their pricing, and we can pick one, is they have some, they do have a free tier. So definitely, think about what you might like to do, and definitely look over the materials so that you can get kind of comfortable with the terminology now with large language models, and hopefully that video will make you far more comfortable with the idea that you can build applications off of large language models without needing to know all the complexity of how it's using these very involved neural networks to do its language predictions. Okay. Excellent. Well, with that, we will wrap up, and everybody have a safe and good spring break.